Hello and welcome to the Foundations of Software Development. My name is Mildred and I am your instructor for this course. Now, this course provides a comprehensive foundation in software development, data structures and algorithms, and also software engineering principles. For this course, it is expected that you already understand the Python programming language, as we are going to use that throughout this course. At the end of this course, you should understand some core algorithms and how to analyze performance using the big O notation. You will also learn data structures like array, linked list, trees and graphs, and how to implement all of these using Python. You will gain hands-on experience of real-world projects, and for those of you struggling to pass coding interviews, this is the right course for you. In this lesson, we're going to introduce algorithm and look at arrays in general. Now, when we talk about data structure, we mean finding efficient ways to store and retrieve data. As a software developer, this is one skill that you will need, as it is a fundamental part of computer science. A data structure is the way and format in which the data is stored for a particular purpose. Now, let's give an example of data structure that we all know, like when we were in elementary school, we were asked to draw a family tree. The family tree is an example of a data structure where we can now see everyone's great-grandparents, grandparents, parents, and the different branches of the children from each uncles and aunts and parents and siblings and all of that in the tree. But for us to create an efficient algorithm, we need data structure. There are two types of data structures. We have the primitive data structure, which are the data types that are provided by the programming language, and then we have the abstract ones, which are the more complex and specialized data structure, like the arrays, the linked lists, the queues, the trees, the graphs, and we are going to look at all of them in this course. Now, an algorithm is a step-by-step instruction, such as maybe a GPS direction to get to somewhere. And when we write algorithms, it makes it easier for us to come up with a solution to a problem and then find more efficient ways to run that solution. Let's do an illustration with the popular Fibonacci sequence. Now, when we want a Fibonacci sequence, we know that the next number is obtained by adding the two prior numbers. So you always start with 0 and 1, and then the third number is gotten by adding 0 plus 1, and then the fourth number, the second and the third, the fifth, third and fourth, like that, and then we'll get a sequence of numbers. Let's say we want to write an algorithm for a Fibonacci sequence. We know now the definition of a Fibonacci sequence. We want to start, I'm going to write this as a comment. We want to have a first step, which is start with the first two numbers 0 and 1. We want to have the second step, which will be add them to get the third number. And we want to have a third step, which will now be update the previous numbers to be the recently obtained one and the one before it to get the next. And then the fourth step now will be once this update is done, you want to continue to repeat it for the number of times, for the number of sequence you want. Now, this is an algorithm. We've written out the steps, and when you write out the steps, the next thing for you to do is to figure out how you want to implement this in the programming language. Let's say we want to create a function, and this function will receive an integer. That integer is going to be the number we want in the sequence. So let's say we want to have the first 20 Fibonacci sequence. When we pass in 20, it should give us the first 20 of them. So how do we do this? Let's create a function in Python, and let's call this fib sequence, or let's just call it fib. This function will have a parameter n, right? So the first step is to start with the first two numbers. We want to add them to get the third number. We want all of this to be stored in an array. In Python, a list is used as an array. So maybe we should have an empty list that will hold any of the number that we have. So let's say fib sequence is equal to, and we'll have an empty list like this. We want to get the first two numbers. Now, know that when you are building an app for production, there are some checks that you will do, like checking if what is passing is a number, check if the number is greater than 0, check if it's just one number entered. If it is two numbers entered, you can just do that to return them. But we'll just go straight to the point here, and we'll say let's initialize the first two numbers. Let's call the first two numbers a and b, and we want to give them the value 0 and 1. So recall that when we create a variable in Python, we can assign values to them like this, like create them as a comma separated list and assign the value like this. This is the same thing as saying A is equal to 0 and B is equal to 1. Alright, so we initialize the first two, which is A and B, and we want to loop through a sequence of range n. So we're going to say for, we can use an iterator I, or we can just use this underscore. Now when we use underscore in Python like this for an iterator, it's just like a throwaway variable. And what this is, when we just need an iterator to iterate through, but we don't really need it to indicate anything, but we just need it to iterate several times and store the result. Once we iterate, we append. We don't need it, so we want to say for underscore in range, and now we want it to be range n. If you recall, during the Python course, we looked at range, and when we want to generate a sequence of numbers, usually increments by 1, we use the range function. We can specify a start and an end and the number of steps. So if we don't want it to increment by 1, we want it to increment by 2, we can do that. But now we want to loop through the number of times that the user will supply. So if it's 5, we want to have range 5. So 0, 1, 2, 3, 4. Alright. And so for the iterator in range n, we want to append to this sequence. The first thing we want to append is the A. So the first two numbers are always 0 and then second number is 1, right? So we want to say the fifth sequence dot append. There's another way you can do this, but we're using the shortest way possible. So fifth sequence will append, we want to append the value of A. Now for us to get the sequence, we want to start with 0. So we want to append the value of A to the list. So now we have A there to the list. And now A0 is already here. So we want to start. We say we have to add them to get the third, right? So when we add 0 and 1, we don't want to append B directly, but want to update the value. What is the most recent value that we have? So we want to switch it to say A and B will be equal to, or let's say A is equal to B, and we'll say B is equal to A plus B. So let me explain the logic again. We loop through the number of sequence we want. We append the first value A to the list. We want to now update the value where every time we get or we calculate a new value, we want to update the most recent to be the last inserted item and then the previous one to it, and then we want to add both. Now because we initialize the value of B as 1 here, we can say A is now equal to B. So now because B is 1, we want the last inserted item now, once A is appended, to become B. So B will be appended next, right? And we want the value of B, which will be the third value now, to now be A and A plus B together like this. You can think of this in a different way, or we can just do this in one line, equal to B, A plus B, like that. Now once this is done, we just want to return the list. So this is a short form of thinking about this logic. You can think about it in a different way, and we can test this to see if it works first before we go. If n is equal to 20, let's print fib n like this. So we have the first 20 Fibonacci sequence. Most time when you write out an algorithm and you finish creating it, you find faster and more efficient way you can come back to your code and review and see what you have done right or what you have done wrong. So this is where we end this lesson. In the next lesson, we are going to look at arrays. Thank you and see you in the next lesson.